Ready?
You're right.
Thank you, Jimmy. We're going to start off, I always like to start off this way. Oklahoma, Texas, and Kansas. How many states, what states are we here from? Kansas? Raise your hand. Excellent. Thank you, Kansas. Oklahoma. Oh, beautiful. Any from Missouri? Beautiful. Missouri. Anybody from Arkansas? Anybody from Texas? Anybody just lost? Let's start off with a very good morning. Good morning. Good morning. Oh, my goodness. That's how we're going to start off today, with that kind of excitement. We're going to learn. We're going to have so much fun today. And please ask a lot of questions, because Gabe, myself, Willie, the guys that are here, Steve, we're here to serve you. And I'm going to start off telling you a little bit, I'm going to find out about you a little bit. Then I'm going to tell you a little bit about me, and then I'm going to tell you about the soil health movement. And then we're going to walk you through this journey for today. I'm going to tell you, by the time that we were done with them yesterday, you can see the blank stares, right, Jimmy? Maybe they thought we're aliens from another world, but that's okay. Let me start off this. How many zero tillers, no till? I mean, if you have a piece of equipment besides a no-till drill, you'll break into a rash if anybody disturbs your soil. Raise your hand. Okay, thank you. How many more kind of strip till, kind of in between no-till and a little more conservation tillage? Okay. How many are conventional till? Raise your hand. Come on, raise your hand. Don't be shy. I was too. Okay, we're going through the 12-step process today. Okay. How many grazers? Raise your hand. Okay, so do wheat, grazing, and how many of you do grazing and your cropping systems together? Raise your hand. Okay. How many are full-time farmers and ranchers? Okay. Now, how many do it? You still have to work outside the house. Okay. Okay. Now, let me see. How many agency people? Raise your hand. Extension. Extension. Great. We have some extension. How about our district partners, our brothers and sisters? Yeah. Any ARS? Any EPA? You wouldn't raise your hand, would you? We still love you too. But they've been coming to our classes too, and they really have been enjoying them. Any FSA, any other agency did I miss? Okay, thank you for coming. And okay, here's how we're going to tell you. I'm going to just tell you a little bit about me. I've been working with the agency 30 years. I started my career in New Mexico. I grew up in the Rockies, married a Missouri girl. We just moved to Missouri now. I had national responsibility for soil health, the whole country. Now, since we started a new division with 16 more people, Willie's one of the new ones, because I was getting tired going over the whole country. So this went NRCS hired 16 more people, took them from the tech centers, and dispersed them through the whole country. Why did they do that? The reason they did it is because of farmers and ranchers. The demand for soil health and learning how to farm in nature's image became so great that the Chief White said, we're going to do this, and this went all the way to the Secretary of Agriculture, and this soil health movement was caused out of pure desperation. I'm going to tell you, we were desperate. Where my story started was started back in 2007 when I moved from Idaho. I had a small farm in Idaho, and my county, as a district conservationist on the Oregon side, is Malheur County. How many of you been to Idaho? Raise your hand. You've been to the Boise, right? They call that the Treasure Valley. The reason they call it the Treasure Valley, there's a lot of things you can grow there. Lettuce. You can grow hops. You can grow anything. It's because it's got this banana belt. Phenomenal place, a lot of water. My county was 6 million acres, 300,000 irrigated acres. It was back then, about 15 years ago, I said, why is my farmers going broke, but also we're putting all this conservation on the ground? How come it's an irrigation season, at my border, the Snake River turns into chocolate? It got so bad that the sediment is filling that reservoir, in the Brownlee Reservoir, and several dogs died of water quality issues. I said, farmers going broke, my own producer that I worked very closely, helped me share my equipment. He says, he could not bring his son into the operation. I said, how many acres of prime agricultural land do we have to farm to be able to bring the son and daughter back? I said, something is wrong. And it wasn't until I became part of the soil health team and met Gabe in 2007, came to his place. It was there I started beginning to realize that I was taught agriculture on the wrong premise. And I'm going to ask this question to you. This is the premise I'm saying to you. How many of you in this room had a relative, a cousin, a grandpa, a father, a mother, a professor, a mentor said, if you're going to get involved in agriculture, your job is to emulate and mimic nature, to understand its synergies, its complementaries, to nurture it, to understand it, to love it, not to force it with our tillage, our fungicides, our insecticides, with our tools. I did not say not use the tools. That's not what I'm getting at. Understand it. Collaborate with it. Understand its complementaries. Raise your hand. One person. I did this in a group, of organic group, with 2,000 people in the audience. Less than 1,000% raised their hand. Today, what we're going to learn, ladies and gentlemen, is we're going to learn how to mimic it. We have producers now. That's why Gabe and Jimmy are here today, because they are down that journey. I have hundreds and thousands of producers that are heading down this journey. And now they are reducing their inputs. I have farmers that no longer use fungicides, insecticides at all in their operation. They have completely reduced about 80 to 90%, all the way up to 100% of their chemical nitrogen. I have 90% reduction in herbicide. This is about you. It's about having you take all the risk. You should get all the reward. And the way you're going to do it is we're going to go this journey and we're going to learn how to mimic it, how to work with it. So here's what we're going to do. I'm going to select 4 of you from the audience to come, and you're going to help me with this demonstration. I have 3 young ladies here. Would you please come and help? There's no volunteers here. And you know what we forgot here, Kim? There's no name tags. We never, ever teach without name tags. This is your class. But please excuse me if I say, ma'am, sir, can you come up? Sir, in the green, can you come and help me? What is your name?
Owen Westfall.
Owen, bless your heart, come down here. Come to the altar call. Here's where I first learned my journey, where I'm going to show you today. What is your name, ma'am?
Claire Barker.
Hi, Claire. It's nice to see you.
Lacey.
Hi, Lacey.
Julie.
Julie, you guys are all here. Were you forced to come here? Tortured? No, you just came because you wanted to learn. Awesome. Come here, sir. You come on this side. You're going to line up with these lovely ladies. Okay. We're going to do what we call the aggregate stability, the slate test. This has been around with soil scientists for years. Unfortunately, this was not taught to me at graduate level soil science. Several years of graduate school in soils, this was never mentioned to me. My professor did not teach me this. And the research has been around for many, many years. The way the test works, we have several clods. This is North Carolina soil, because I just moved from North Carolina. So I brought some of my North Carolina soil. This comes from Ray Steyer's field. He's 82 years old. He's been no-tilling since he was in the 70s. He bought one of the first no-till planters. He's been doing cover crop mixes for 30 years before they became sexy. His organic matter, ladies and gentlemen, is 5.5%. The natural forest is 3%. The typical agriculture soils in North Carolina are 0.5% to 1%. Sounds like Oklahoma, huh? Or New Mexico, where I grew up. Very low organic matter. How can you get up to 5.5%? We'll talk about that in a while. Hold on, Matt. Now, here is the other North Carolina soil. The typical conventional, no covers, lots of disturbance. When I use the word disturbance, I mean physical disturbance, lots of tillage. Okay? No covers. Typical rotations. You're going to hold that. Usually I'll let the boys hold the conventional because they're more disturbed than the females. But it's okay. We're going to switch this time around. I have 3 daughters. I know. My wife tells me all the time. Okay, you're going to hold the conventional. You can drop some of these in there. You're conventional. The 2 ladies in the center are conventional. This is our beloved Oklahoma. We just collected the soil over there. So I always got to get soils from the area where I go teach. Because if I do North Carolina soils, you're going to say to me, boy, it sucks to live in North Carolina. It only happens there, right? Now, Oklahoma. This is a wheat patch by a telephone pole. They can't get to it with a disc. Because if they could, they would. I'm hard on myself, you know, when you're a recovery killer, hey, I know. Now, here's how the test works. I want everybody to do this on our own operation. I want you to do it. How many of you guys have ever watched the Mythbusters on TV? Mythbusters. Isn't that cool? What did I tell you? Don't do this in your house, because I'm a professional and you'll hurt yourself. The only thing here will hurt is your feelings. Okay? This is going to show you, it is one indicator of soil health. It is only one. But it is a very powerful and visual. It's called the slake test, aggregate stability. They're going to gently drop this in these tall cylinders of water. Water is going to rush in to fill the pore spaces. There's going to be internal pressures building up. If the soil holds together, it is an indicator that the biotic glues, the organic mineral complexes, some people call it glomalin, created by fungus, bacteria, organisms, root exudates, by living biology, and some chemistry, the majority biological. So, you drop them in, we don't want them to fall apart. If it collapses, and it falls apart in the column, that means the pores collapse, and if the pores collapse, no porosity, no infiltration. And the water does not go in, and that precious rain that you're waiting for stays on the top, does not infiltrate, and it evaporates. We do not want it to fall apart. You ready? Drop them in. Hey. Now notice this. Oh. We've done this in Alaska, Puerto Rico, Hawaii. Same thing occurs. Look at my beloved North Carolina and look at Oklahoma right by the telephone pole. With weeds restoring the soil function. Look at here, Oklahoma falling apart, and look at North Carolina. Just watch as all of it falls apart. Now, if I grab a forest soil and put it here, now audience, I'm going to call on you today. You did not come here to learn passively. I want to make everybody feel comfortable. I did not know this 10 years ago. Okay? This was through progressive revelation. The right people, the right books, the right researchers, the right professors. What is happening, audience, to these soils right here? What is tillage doing? Come on, audience. What is breaking up, honey? Why is this such a big issue? When you run that disc, that vertical till, you pay 50 grand for to destroy your soil structure, to hurt the soil biology. What is it doing? Come on. No lunch if you don't answer.
Destroying organic matter.
It's destroying organic matter, and how's it doing that?
soil is seen by oxidation.
You're exactly right. What you soil is what you break up that soil, exposes it to air. The air stimulates, according to the research, the hypothesis, you wake up these bacteria called R strategists, rapid composers, rapid metabolic. They are called rapid strategists because they eat these very complex, simple carbon compounds. There are the K strategists. Think of Archuleta, R strategist. My wife is the K strategist. Mellow, easy going. She'll eat the more resistant material. The R strategist, we want the ice cream. We break those molecules, we'll eat them. They go off into CO2. The pore collapses. You create that crust. And then also, they die. They release nitrate back into the system. You wake up the weeds, feeds, because the scabs come up. When you till, you disturb, weeds come up. You stimulated secondary succession, woke up the weeds, and when the microbes die, they release nitrate. You did that all in one event. You destroyed the soil structure, you decimated the fungus, you altered the biology, structure falls up. We're going to show you for the big rain simulator what happens. Now, you're going to say to me, my wife's from Missouri. I had one guy from Missouri says, "Oh, Ray, you put a rock in here." Let's break it open and see if all the water entered in there, okay? Go ahead and open it up. See the water all the way entered. Oh my goodness, it all entered. Well, let's try Oklahoma, okay? We let this soak all the way through. See if that will open up. Open that up. That one didn't get to sink all the way through. Did the water all go through?
Yes.
Now get your hands over here, both of you guys. You can rinse here. Now, let's make this very clear. Tillage is not your friend. It is the most intrusive thing we do in modern agriculture. Nature does not till. What does she use to aerate the soil, audience? Earthworms, the critters aerate it. And you know what I like about them? They don't complain. I don't have to put diesel in them. All I got to do is feed them. Carbon. Carbon is the most limiting nutrient in our soils. I'll say that again. Carbon. The carbon in this soil is functioning. This soil, by the way, North Carolina, 45 inches of rain. Every summer, we only get 10 inches of rain. Ray Stiers grows a whole crop of corn, and he's 20% above the county average with only 10 inches of rain. The neighbor doesn't get anything. This soil, now, I can graze this soil. I can allow my animals to graze it because it has the structure. This one, I will not allow my cows to graze in the conventional because they will collapse and they will compact. Well, don't get me wrong. Can you compact a soil like this? Absolutely. That's why cows say, moo, move me. It's a function, compaction is a function of time. And let the carbon be tall so that you protect that soil. When I have soils like this, the pivot no longer sinks. The wheel's right on top. I could never explain that. Now I can. The biotic glues are present. The structure is intact. This is a functioning soil. This is a non-functioning soil. These two soils are bacteria dominant. They're leaky for nutrients. They leak calciums. These soils are not functioning optimally. Okay? Let's go one more demonstration. A couple more demonstrations. Stand in front. Please come here. Like a mugshot. Wanted for tillage. No, I'm just kidding. There we go. You're going to be my rain cloud. I lost my little thing. We're just going to pour, okay? These wonderful ladies of the no-till, low disturbance, high disturbance. All I'm going to ask him is to pour the water on top of the clods. And I'm going to talk about it. Go ahead and pour and see if it can hold that, just that gentle force. And what happens? I forgot to tell them the one they get, they have to drink out of. No, I'm just kidding. That sucks for them. Raise that up high. Get it close. Ladies and gentlemen, do you guys get wind erosion here? Every day. Now you know why. These glues only last 27 days. If we're not continuing building glues, the clay particles detach, all the particles detach, and then you have them in the atmosphere. This is why our lakes look like chocolate. Because these tiny, minuscule clays will travel for miles. Look at this one. And this soil is a sea salt sandy clay loam. It's inherently not a good soil. But I will stand that soil to Iowa any day. Because it's functioning. It was biology that did this. It is microbes, fungus. Your soil, ladies and gentlemen, are alive. I had a 65-year-old man, after he came to my class, he said, "Ray, do you know what you taught me? My soil is alive." I smiled, went to the back of the corner and began to cry. Because if you understand it's alive, it's the beginning steps to give you financial freedom. Now, what do we do to fix it? Let me show you one more demo. And then we're going to go outside. How's that? Perfect. He says, "You're such a lovely contributor. Would you come over and help me?" You guys just watch here. I want you to show up because we're going to pass this bucket around. Now, what are we going to do to heal the soil? Any suggestions in your mind right now?
Growing crops.
Cover crops, a living cover 24/7. You never leave that soil bare because you stop the energy flow. We'll talk about it. Let's talk about how powerful the plant is. This is called the Scum test. This young lady is going to get this chunk of soil, and you're going to dip it, and you're going to swish it around like you're washing some old clothes. I mean, vigorously.
What did you call
That's all right, you can splash it. We'll just blame it on me, okay?
Right.
Yes, ma'am. Sir. Yes, sir.
Would you say the name of the test?
It's called the Scum test.
Scum.
Go up and down. Yes, very good. Now, isn't that awesome?
That's great.
Okay, now, fantastic. Now, we'll just go ahead and put this here. Now, we're going to pass this to the audience. Would you tell the audience what you see right here in this white, do you see that white frothy material? Okay, that white frothy material is liquid sun. It is byproducts of photosynthesis. The moment the plant captures the energy from the sun, it converts it chemically. That chemical communication leaks into the soil. Depending on the function of the soil, it can leak up to 30 to 70% of its energy. If the soil is really degraded, it will leak 70% or more of its energy to the soil. Why would the soil leak so much energy into the soil? Why would they leak so many carbon molecules? They are sugars. There are amino acids in there. They are negative communicators and positive communicators. There's citric, oxalic acid. There are thousands of compounds leaked into that soil. Why would they do that, audience? Come on, audience. Why would the plants do that?
To feed things.
They are feeding the soil microbes. They say, plant says to the microbes, "I am here. I am communicating to you." It's like the little iPhone, and they're saying, "Microbes, let's have a relation. Fungus, I give you sugars and food. I will get the phosphorus out of the rock. I will bring iron to you. I will bring nutrients to you. I will help you make nitrogen." See, when I got out of graduate school, I thought it did it by itself. Ladies and gentlemen, what happens when we put chemical phosphorus out in the soil? Here. Come on. You're farming. You put phosphorus, very expensive stuff. You put it in the soil, what happens to it? It binds up. Who unbinds it? The mycorrhizae do. The fungus, the bacteria. Bacteria release phosphatase in concert with the fungus. And they take it back to the mothership. It is biologically, 90% of nutrient cycle is biological. And when I went to graduate school, it was dismissed. Was I the only one who went to the graduate school that way? Or taught? I don't think so. Because I go all over the country and I see the same. No more. This is causing us to go broke. You understand it is biologically driven. Please give these guys a hand, would you?